Hey folks, so a very common exam question they'll ask you is what happens if you change the load resistance to the EMF or the VTP rather in a circuit. So this is my circuit here. So just to show you, I've set the internal resistance to be 5 ohms and we're measuring the EMF just now because the switch is open, so there's no current flowing, and you can see that because the ammeter is reading 0. Now, a bit that people get confused by is if I close the circuit here, I've still got the voltmeter connected across the cell, but I am now measuring the Vtpd. How do I know what the voltage is measuring? Well, if the switch is open, it's measuring EMF, okay, because there's no current flowing. If the switch is closed, it's measuring the Vtpd. And I can show you that because if I move this across, you can see it's still got the same value of 6 volts. Nothing's changed. Okay, so I'm going to leave this over the cell here. And remember, we're measuring the Vtpd. Now, what I'm going to do, folks, is I'm going to change the value of my resistor. So first of all, let's decrease the load resistor and let's make it at about 5 ohms. Now you should have noticed first of all the voltage has dropped from 6 volts to 4.5 volts and the current has increased. So in general, if we decrease the resistance, the VTPD will decrease as well because we are now losing more voltage across the internal resistance, i.e. loss volts has increased. Now, if I increase the resistance, okay, so let's make it up to 15 volts, you can see that the VTPD has actually increased from 6 volts to 6.75 and the current has decreased. And the reason for that is because you're losing less volts across the internal resistance, i.e. loss volts has decreased, so your VTPD has to increase. As always, try it yourself and convince yourself that that's actually true.